Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be, good afternoon. What I will be discussing will be the so-called importance of heatsink in electronics. Heatsink are actually used to dissipate the heat of high power electronic components like this is a diode maybe. This diode supplies or rectifies what's coming in here. So this diode actually passes high current. So if there is high current, supposed to be there's a heat dissipated. The top portion, which is a metal thing, is actually the heatsink. But in electronics, to prolong the life of a high power electronic component, we used to install a heatsink. It's just like the transformer on the post. There are some cooling pins to dissipate the heat inside the transformer. But for electronic components, we use the so-called heatsink. Any type or any form of any what you call this aluminum thing, okay, connected to the heatsink body, okay, if there is a heat generated in the heatsink, it will be transferred over here. And that transfer of heat actually is not so much because this heatsink is very big compared to the heat it will absorb. So to prolong the life of high power components in electronics, we use heatsink. The one I assembled, this one here. Okay. This is a 3.3 volt voltage regulator. When I used it yesterday after the assembly, I feel it that it's hot. So to prolong the life of this 3.3 volt voltage regulator, okay, I got some heatsink over here. I just remove it, then I place it here. Okay, I screwed it. So the heatsink portion is this one. So I put beside it the heatsink which I got it from this. Okay, and I think this will be more than good enough to dissipate the heat generated by this because when I felt it yesterday, it's a little bit hot. And actually the equipment plugged into this 3.3 volt regulator is just the AM FM receiver that I have assembled. So meaning to say that FM receiver is consuming a little bit high. That's why this 3.3 volt regulator is hot. There's nothing wrong with it. Normally, a power component, okay, when current passes through it, will experience some heating. That's why when we buy the regulator, there is a heatsink connected to the top portion. And to expedite more the dissipation of the heat, we added the so-called heatsink. Okay? Actually, I am missing something here because in between the heatsink added plus the heatsink of the regulator, there should be some what you call this it's effaced place in between so that the transfer of heat from the heatsink of the regulator to the heatsink which was placed will be faster. But anyway, without it, as long as the connection is intact, and it's screwed, so this is very tight. Okay, whatever heat that will be dissipated by the small heatsink of the component will be transferred to this, and it will prolong the life of the component. Okay, that's the purpose of heatsink in electronics. Okay, so the components which are actually with heatsink are actually the rectifier diodes, the high power transistors which are used in the so-called amplifiers. So if you try to open an amplifier, there's a big chunk of metal thing, and that part is actually where the power transistors are actually mounted, because power transistors for big amplifiers actually passes big current when you try to increase the volume, you know. And normally, high power amplifiers experience a high current. That's why inside there's a big chunk of an aluminum thing in which the power transistors are actually mounted. Because the power transistors, whether we like it or not, they will be hot while we are using. They will be hot. So to dissipate and to prolong their life, they are mounted in a heatsink, which are usually something like an aluminum thing. Okay? It's mounted. So for the 3.3 volt regulator, it's not so hot, but it's hotter than the normal thing. So I think it is just but proper that I will put a heatsink. Okay? So I'll be plugging in this one now. Actually, the load of this one is actually my AM FM amplifier. And if I'll try to plug in this one, so I could power up my see? It's working.